let's start with data modeling. So here, what is data in general, in your way, in your terms? What is data?
Data is like some fact or information of attribute.
Yeah, okay. So it's about some fact. Okay,
Mm.
it's about facts, raw inputs. I can say instead of data, we say raw inputs. Instead of saying factorial information, why I tell you what is information in your words?
Something relevant to a particular
Yeah,
attribute.
no problem. No problem. Yeah, information is tuned data or filtered data or processed data. I'll give more examples, simple examples I'll give to make you the differentiation. Let's say mm, we all belongs to the school. Okay, in the school, all data is maintained, right? How they maintain? In books they maintain. Okay, let's say we belong to the same school, same classroom, and we write many exams, quarterly, monthly, quarterly, half yearly, again monthly, correct? So
Mm.
we write
Mm.
many exams. What class teacher do? Class teacher makes an entry of all our exams, of all our marks across exams, across subjects. Means here data is gathered across students, correct? Student names, I mean,
Mm.
across students, across subjects, or across exams, and across subjects. And they are stored in a book. Yes or no?
Yeah.
Yes. So now, let's say after half yearly exams, my parents came and they want to see what's happening about their children's status, and they ask about, can you please let me know how my son is performing? Okay. So let's say my father came and asked when they came to pay the fees, they asked. So what they do is they take my father into a guest room or a staff room, make him sit and provide a book, go through this. So what is the problem with the father is my father is he don't know how it is organized first, correct? So if I come to
Yeah.
your home and if you ask me go and get me a book, see we sat, we are discussing, and you ask, hey, can you get me a book there? So I don't know how your data is organized in your home, correct, or in your room. Same. So later he found out there is student wise, exam wise, subjects are there. So he'll find the exam wise, subject wise, and note my marks in a notepad. And he'll note all month wise, quarter wise, half yearly wise, everything he'll make in a book. Okay. So he may took 15 minutes to crack this or 20 minutes to crack this. After that, he won't be calm. He find Aniket is friend of my son, so let me gather his marks also. So he may waste 10 more minutes. So he's spending lot amount of time to gather this data. Yes or no?
Yeah.
So data is stored. Of course, data has to be stored. Data is stored. So this is a major challenge. During this time, let's say your parents came and your parents has to wait for the turn. Correct?
Mm.
Maybe that
Yeah.
book is one book. It cannot be maintained multiple copies because everything is manual written. Okay. To overcome this problem, what schools did after years? Okay. Very first, this was a status. After years, they recognized that better to give a progress report instead of let parents come and pay fee and leave. Every parent is coming, every parent is paying the fees, every parent is waiting for the registered book to understand their children's status. And to maintain this, there is one employee or class teacher who is assigned permanently for to manage this parents. To overcome this, they introduce a concept is where there will be student details and exam wise marks. Only one student, okay? Exam wise, subject wise marks for one student, correct? Only one report for one student. They enter that into this report and they send to the home, okay, to get the acknowledged from the parents. After seeing this, parents just by seeing it they can understand. Yes or no?
Mm. Yeah.
Progress report is very simple. Exam, this
Mm,
is on top, subject wise marks. Okay, total rank is what. So just by seeing it, their children are performing, what is the weakness, what are the strengths, how to balance, what is extra care to be taken, everything they can understand. Just by seeing it, they can understand, and this is for the particular student, not of all the students. That is what information, which is filtered, tuned, and processed to make the end user understand at a glance. Got it?
yeah.
Yeah. So these are about data and information. Okay. When you say about data, we can still classify like data is can be quantitative or qualitative, qualitative about some objects. Those are called as variables, correct?
Yeah.
So whenever we say quantitative, what are the quantitative things? What are qualitative things? Okay, variables are nothing but your attributes, or it could be anything, or tables, or whatever, how you store. So what are these quantitative and qualitative observations is what data is about. What is this quantitative? Quantity. So quantity, how you say? You say in numbers, okay? 5 feet height, 10 kilometers, correct?
Yeah.
2 kgs, 1 liter, and so on so degree centigrade, correct?
Yeah.
Or Fahrenheit. So basically, you are telling the quantity with respect to some measure. With respect to some measure, there is a number when you say quantity. How many books you want? Number of books. How many packets you want? Number of packets. Quantity means basically it is a measurement in terms of numbers. You know it. No need to say anything you say. It can be sweets, or it can be tables, or books, or mobiles, or headphones, whatever. Any object, any data you say, it's about numbers. Correct?
Yeah.
Okay. Coming to qualitative. What about qualitative? How you measure qualitative? How you measure quality? So let's say if I give a perfume, how you measure the quality? You are going to see
Yes.
the
Fragrance.
you are going to, yeah, you are going to smell the fragrance. Let's say if I give a sweet, you are going to taste it. If I am asking you to go for a shopping and get me a nice shirt for your birthday, so you are going to buy a nice shirt by touch. First touch. Of course, you are going to wear it, check it whether it suits to your body, whether it looks good or not. All this is okay. First, you are going to touch the material. So feel. You are going to touch it. Correct? So let's say if I give a video CD and ask you to play and get whether the what is the quality of video, you are going to play it, see it with your eyes, listen it with your ears, and come back to me and say the quality. Same with any music if I ask. So basically here the quality observations are involved with your brain, involved with your senses. It is not so simple as quantity. It requires additional manual inputs to define and decide the quality of the particular product. Yes or no?
Yes.
Yes. So when that's how you are going to classify the data is quality enough, data is not quality enough. So here data can be of anything, but these observations help you to keep clean data. Okay. So quantity, quality, variables or set of variables we call nothing but these two combinations of data. You are grouping it. You may get a question, what is this we are discussing about quantity and quality? What about other data? Okay. That's what qualitative describes to the data. Description. Okay. Even names, all are data only. But whenever you say data in terms of data warehouse, you remember in data in sense always we discuss about fact data, you know.
Yeah.
Yeah, others we always simply say as dimension. Fact is said to be as data. Why? Because it mode is about calculated data, that is numerical data, which can be measured. Okay, that's what quantity. Giving the info about how much quality is enough, that's about qualitative observations. Are you clear on the data? Concept of data,
Yes.
you are clear?
Yeah.
Information, how you are clear, right?
Yeah.
Okay, so with the help of this data, we are going to derive information. With the help of information, we are going to present the data to the customer. Based on that, they are going to take the decision. Okay, this is called as a business intelligence. Okay, which is helping you. At the same time, this also helps you how you can organize your data in a better way. Okay, so these are all interrelated topics. Okay, anyway, now next step. Okay, you know about data, you know about data, you know about information. Now you need to organize your data. That is the main thing. Organizing your data itself, the modeler role. How you are going to ask your developer to organize the data is, you divide the rooms for him, you divide the rooms for him, he will come and store. That's what the data modeler is going to do. We are going to give the room for the developers where they come and make the data sit. This data modeling can be implemented or is generally implemented with 5 steps. Okay, data modeling is, or data model is implemented with 5 steps. Very first step, you know it, without requirements we cannot go. Requirements gathering is very first step. So we are going to connect. Whenever we say we, it's data modeler, a data architect. And whenever project starts, what it is going to start, it could be a database related project or a front end related project or any project you say, or it could be automation project, or it could be, yeah, artificial intelligence project. You say, you name the project on that particular domain, on that particular technology. Everything comes on the place. First step is business requirement. Next step is architect. Without architect, nothing goes. Yes or no? In simple, you have a plot, you have a land, and you want to construct a house. What you do? First, very first, you have your list of requirements. Then you are going to consult civil engineer and explain the business requirements. Yes or no?
Yeah. Right.
Let's say you have a very big land and you want to construct very big apartments. What you are going to do? Still, you have list of requirements and you are going to consult civil architect and get the suggestion. Okay. You want to build a theater, whatever you want to do, what you do first thing is you are going to consult civil architect first. Correct?
Yeah.
So first is of course requirement gathering. What you do based on your data, based on your data, based on cost, how much you can invest. Okay, client has all the inputs. Okay, and you as a data architect, very first person in the project, technical person, especially in the project, very technical, very first technical person is data architect, or simply to say architect. It could be any project I said, right? First will be architect. Every no side of the .NET side, there is .NET architect who is going to understand and define the solution for them. Okay, so same way, requirements gathering, coming to this, clients share requirement gathering with data architect. Okay, so data modeler receives all the requirements, understand the requirements. Okay, and gives a word, we need so and so time. So here data modeler collects requirements, understand the business, of course all one and same business needs or business, and he is going to define hardware and software needs for the project. Okay,
Yeah.
this involves costing, that's a different area. Okay, this involves costing also, that's a different area. For now let us keep aside. Okay, because whenever we say hardware software needs, all the tools which are required, database software or any other drivers. Okay, all those things are coming under it. So costing can be defined later. This is the first need. Second one is defining conceptual data model. So from your college days, if you remember, okay, from your college days, if you remember, in the final semester, you would have done a project, yes or no?
Yeah.
So when you do this, before doing it, you go to your project coordinator with a document. Yes, correct?
Yeah.
Yeah. So what they do, they approve your document. Basically, they approve your business case or your project. So what is the document? You are going to take 2 pages document, right? What is the document?
Uh,
That is called
for
as
the requirements.
abstract. Okay.
Uh,
Remember? Do you able to recall your college days?
yeah.
So we used to build as a team, 3 people, 4 people. We are going to pick one business problem. We are going to write it up in an abstract, which is of 2 pages. What is the problem? What is the existing solution? What is the proposed solution? Correct? And we take it to
Yes.
the project coordinator. If they approve it, well and good, we go with that. If they don't approve it, we are going to go with a different objective. Correct?
Yeah.
So this is what that is abstract. Abstract means not clear, conceptual, not clear, very much high level, very high level data model. Okay. So here
Oh,
architect is going to consider what are the entities possible in the data model. Whenever we say entities, those are tables only, but still these are not really existing in the world, existing in the database. So these are called as entities. Okay. What are the entities possible in the data model? Next, what are the high level relationships? How they are related? Okay.
um,
Possible relationships between the tables. Okay.
yeah.
Clear? Okay. So this is a very first step. Once this is designed, again, this is designed using data modeling tool. Using data modeling tool. Once this is done, this gets sent to SME. Even there will be a person from testing side, senior technical lead or whoever from the testing side, because they know the functionality. So they also see this, they also understand this. Not much technical. This is completely on the logical. Okay,
Mhm.
how the requirements are and how they can be implemented. So once this is approved by client or SME, everyone, then we go for logical data model. Logical data model means here all the possible entities and okay, here all the possible requirements are considered. Okay, even
Yeah.
if they are not possible to implement practically. See, we need to consider all the requirements. Not possible, sorry. All the requirements are considered even if they are not possible to implement practically. Okay,
Yeah.
all the requirements simply consider. Don't bother whether they are able to exist or not in future. They are possible to exist or not in future. Don't consider those. Consider all the requirements. Okay. So here we define the entities, define the attributes. Attributes means columns. Okay, and define the relationships. Okay. So
Yeah.
here we are going to consider all the requirements even if they are not possible to implement practically. And we are going to define the entities, define the attributes, means columns, define the relationships. Okay, whenever we say relationships, definitely you might know about one-to-one relationship, one-to-many relationship, many-to-many relationship. Apart from that, we have in the tool level, we need to know about identifying relationship and non-identifying relationship, subtype, subtype or super type. Okay, these concepts you'll get to know anyway when we do the practicals. Okay,
Yeah.
then once this is approved by everyone, let's say finally I'll say client. Okay, so client will be happy to see, okay, all the requirements are there. Then we'll say a note, okay, all may not be possible to. So finally we do physical data model. All this based on the normalization concept. Whenever we say data model, okay. So here only the possible requirements are considered. Okay, possible requirements which can be implemented practically are considered. Okay, only the requirements, only possible requirements, or I say only requirements which can be implemented practically are considered. Okay,
Yeah. So what's
okay.
the difference between this basic difference between conceptual and logical?
See,
Why we have it
conceptual you'll have
separate?
only, see, why means this is a life cycle whatever we are discussing.
Mhm.
So client need to understand whether we can do it or not. We are going to do first high level conceptual, which just tells about this will be the positive tables. Possible means that might be there, that might be extended, that might be reduced also. Okay,
Mhm.
high level overview, like a blueprint, rough blueprint. When you start constructing the blueprint, we give all the possibilities, but finally when the construction comes to a kind of 30%, we'll give the actual possible blueprint practically. Okay, practically
Mhm.
possible blueprint. Okay, here only the requirements that can be implemented practically are considered, not all. And here we are going to define the tables. See, we are coming to the real world, we are going to define the tables. Okay,
Mhm.
entity
Yeah.
means real world object. You can see employees, departments, students. Okay, everything, customers, branches, these are all real world entities which are real world existing objects, that is called as entity. Okay, here we are converting into technical terms, that is tables. We are going to define the tables, we are going to define the columns, we are going to define the constraints. Constraints means primary key, unique, check, whatever possible I'm saying, default, and so on. Even whenever we say define relationships, here foreign key comes to picture. Okay, along with that, we are going to define data types of the columns. Okay,
Okay.
so what data is possible to go and sit in the table. And once this is done, again this should be approved by many people. Once this gets approved by client, okay, still database is not existing, correct? We are defining only, we are defining only the model, still database is
Mhm.
not existing. Okay, now before defining this logical model, at least here we need to define the software, database software, I mean. Okay,
Mhm.
like are you going to use Oracle or SQL Server or which one? Okay, because when you define this, when you convert this into this, we are going to convert logical model to physical model. Okay, so that new corrections, some corrections happens, And here data types will be part of that particular software. Few data types does not work here and vice versa. Correct?
Yeah.
Correct. So the data types which are in Oracle may not work in SQL Server. What are in SQL Server not works in Oracle. That is the reason we have to define first itself which tool you are going to use. Accordingly, you will get the data types. So let's say you define the physical data model and later you identify, hey, I want to go for a different software. Then you have to change the software and you have to edit the data types accordingly. It's a rework. Okay,
Yeah.
agree with me?
Yes.
Okay. So then you design it, everything got approved. Now they say, come on, go and create the database. Let's say you define some 50 tables and each table is having more than 10 columns. Who is going to create this table? Database developer? No. No one comes forward to define so many tables manually, so many columns manually, so many relationships, constraints manually. Correct? It is
Yeah.
not easy job. It is kind of data entry job, not technical work. So if you ask to write people to load the data from one so and so source to so and so target by writing SQL procedures, they are ready to do lot of they are ready to write lot of code to ship the data, but not ready to create tables, establish relationships. To get this done, okay, to get this done, we have a final phase, okay, database creation phase from the tool only. Okay, so using data modeling tool, we can define we can define the database name and click on create. We have an option create. Click on generate. We'll get an option to generate SQL. So all the tables, relationships, constraints, everything, data types, everything gets generated on a click. You just need to take that copy and go to your database and execute, so that your tables, relationships, everything comes into your system. Okay. Or some data modeling softwares has an option to create that also, generate scripts and execute. Okay. Generate SQL and execute, that button will be there. Some database and some data model tools, when you click on that, you will get SQL tables automatically created in your database. Okay, with all the relationships, all the constraints. Now database is ready. Now database developer comes and tries to load the data from different places, or a ETL person comes and ships the data from files and some other sources to this. Database developer comes and start writing stored procedures and functions which are required. Okay, are you clear?
Yeah.
So this process till now what we discussed is called as forward engineering for data model. Agree with me?
Yeah.
We are defining this considering you are getting a new requirement. That's why requirements gathering from scratch I started. Okay. Any
Yeah.
questions till now?
No.
This complete end-to-end steps is called as data model lifecycle. Okay.
Yeah.
Yeah. So this is about data model lifecycle. We are going to go to reverse engineering also in practical. What is that reverse engineering we are going to see? Any questions till now? Let me know.
No, that's fine.
No. Okay.
Also along with some live examples and the scenarios so that you can think about the data modeling part and can create a data model during the session as well. Okay,
Mhm.
so not in full fledged, but once you go through all those things, then you will be able to draw a flexible data model. Okay, so that can be ingest n number of types of data inputs and create a data model so that it can be used easily by the developers, by the architects, by the business analyst role, and different stakeholders also. So when you're going to showcase any of the view or a data visualization part, okay?
Yep. Mm-hmm.
Your first question is what is data model? If we talk about a data modeling perspectives, so a data model are built around the business needs. So what we generally do, suppose we have a business requirement to ingest some of the data inputs or a data sets into a model, and then we want as a stakeholder, as a business, as a customers, to view some insights from the data. You got my point? So the basic things to ingest the n number of inputs into a model, and from that model we can get the more insights. So we can say in single line, a data model is just a building process around the business needs that is going to design a model in such a way so that it can ingest n number of data or the data from the different sources and can then visualize into the system so that the visualizations can be represented against the business users, against the stakeholders, against the senior management, or and number of users things. Okay.
Mm-hmm.
Yes. So the data model can be the data can be modeled at various level of abstractions. So when we talk about the abstractions and the data, so it belongs to a term ETL that you already know, I think. Okay.
Yep.
Yep. So ETL basically is also a part of data modeling in which we do extraction, transformations, and the loading part. Okay.
Mm-hmm.
And in ETL, the such process we are going to use in sometimes Informatica, also Cognos, also, and so on, so that we can extract the data sets from different sources, load into a staging table, then going to transform it, and when going to transform, we applied the business logics and the calculations. So,
Mm-hmm.
and then look into a target system. But before loading into a staging server or a target server, we are going to use a data model. Okay?
Mm-hmm.
Because a data model, what we have as a data modeler, what you are going to design, that will be the uh, design of that database. It means the table architecture, the attributes that you are going to define as a data modeler will be the final tables in terms of relational tables or in terms of fact and dimensions tables that will be. Okay.
Yep. Mm-hmm.
So if anyone is going to ask, so why a data model is important?
Yeah.
So a data model is important to make the visualizations, to make the data integrity, to make the data manipulations and the flow easily for the developers, for the architects, for the business analysts, and for the stakeholders. Because you have created a data model in such a way so that it can ingest all types of data into the model and can store the data into a data warehouse or a database.
Mm-hmm.
Okay.
Yep.
You know the differences between the database and the data warehouse. I'm assuming.
Yeah. One is OLTP and one is OLAP. Yeah.
Yes. If there will be a transactional data, that is called a database. If there will be a historical data like the OLAP, then it will be a data warehouse.
Mm-hmm.
Okay.
Yep.
So similar way, uh, a data model helps. data analytics and database architects to prepare data for analysis to gain insights into strategic company decisions.
Mm-hmm.
Okay, so similar it is written. Go to the next slide. So see, so what is the purpose of a data model? Similar way to communicate the system requirement, interactions with data, and the potential outcomes. So this way, I'm going to highlight this line with different color because this is the needs. Okay, the main purpose of data model is only these things: to communicate the computer system requirements, interactions with the data for the potential output or the potential outcome. Okay,
Mm-hmm.
so we have three types of data models. I already told to you
Yep.
yesterday: physical,
Yes.
logical, and conceptual. So the physical law data model is just a blueprint of a database, what you think and what you analyze during the discussion. So suppose in live scenario, what happens generally? So the company got a project and involves some data modelers to work on it first. Okay. So in the first phase, when you get the requirement from the customer or from the business users, you're going to analyze the data. First thing, you're going to analyze the data and the metadata. Metadata, you
Mhm.
know?
Yeah, it said it's some information about the data.
Yes, it is also called the data about the data, since what are different the column types, what are different the data is coming, what will be the length, what will be the data type of this. So all those things we are going to think on a metadata type. So data about a data. Okay. So in physical data model, we are going to just think a blueprint of a data model. So what we are going to create and how it looks like. It's not on any paper, it's not on any database creations and so on. Just a thing. Suppose uh, I'm just saying, so you're going to create a banking system, okay? And for that banking system, you have to create a data model, okay? So in the first phase, what will be your approach?
Yeah, just like we would like to know just like what is the business process and how do we represent that business process basically. Just like
Yes,
right, just like customer is there, customer is a party, um,
yes,
and in loan there is a loan or a credit card is a product, right?
yes,
Address, what is the address of the customer, and
yes,
whenever customer buys a loan, so there are some events as well, events whenever something happens, right?
yes.
And there I think more, there are more processes also. So basically to represent the business process we need the data model.
Yes. So, to know about all the business, okay, that we are going to convert into a model, first of all, we need to E2E business process of any of the business type, any of the areas. Like it will be a e-commerce, it will be a banking and financial domain, it will be a retail, it will be a telecom, it will be a pharma domain, any of the domain. So we must have to know the E to E, end-to-end process of that business. Okay.
Hmm.
So in a banking and financial services, first we need to find out what are different types of entities that we have. In terms of their manual system, we must have to know about the modules and the functionalities. Okay.
Hmm. Hmm.
modules and functionalities, why we are going to ask?
Yeah, just like uh, modules would be just like would be the subject areas, and functionality would be the how they are related to each other.
Yes. So you've gone through two types of diagram in databases. First is the entity relationship diagram, and second part you have gone through in the data flow diagram. That is called the DFD. Okay.
Mm-hmm.
So why in the DFD what we are going to define in the first level of DFD, we're going to define the different modules. You know the DFD, data flow diagram.
To some extent only, yeah, not to a great extent, yeah.
Okay, okay, no issue. I will explain in next class what is DFD. Just a brief for you for today.
Mm-hmm.
So,
Mm-hmm.
in simple relational data models, we are going to create two things mainly. The first thing is the ER diagram, that is called the entity relationship diagram in relational database, and that is going to extend the same thing here in our data modeling part. Okay, but
Mm-hmm.
this is called our dimensional model, having three types of data models like the physical, logical, and conceptual. And that ER diagram is called our relational model.
Mm-hmm.
Okay, and this is called the dimensional model of a system. And having a dimensional model of a system, so these are the three types of dimensional model, and these physical, conceptual, and logical model comes under dimensional modeling.
Mm-hmm.
Okay, but so just a back from a database concepts when we are going to create a database, design a database, then we have two things. First things, a DFD. So DFD basically called a data flow diagram. So we have DFD. Okay, then we have why we are writing here, because we are going to explain. Okay, so that we
Yep.
can, yes, data flow diagrams and a data dictionary. Okay, and a metadata. So when we talk about a relational databases previously, before coming the data modeling concepts, then we gone through two things basically. The main thing, the first thing is the data flow diagrams, and second thing is the ER diagram. ER diagram is nothing, just a entity relationship diagram. Okay,
Mm-hmm.
so in DFD we think about the modules. Like in first liner of DFD, we are going to showcase. Suppose we think about a hospital management system. Okay, then the main functionality of hospital management system is to a doctor treats a patient in one liner. Okay,
Mm-hmm.
that is the DFD. But when you go enter into a DFD and going to explain multiple models of a hospital management system, then that will be our first level of DFD. In first level of DFD, we are going to define the different modules like login modules, like registrations modules, like patient modules, like the doctor modules, like the wards and um, staffs modules, so medicines and all those things. Okay, so
Mm-hmm.
the main models that we are going to consider will be our first level of DFD. In
Mm-hmm.
second level of DFD, we are going to define each process within one model. Okay, so what we are going to define? We are going to define each process within a model.
Mm-hmm.
So this is the basic concepts of DFT. But in ER diagram, we do the different things. First of all, we are going to consider, or we are going to uh, think about the entities of a system. Like
Mm-hmm.
for a banking and financial services, the entities will be first bank, second will be the customer, third will be the accounts, fourth will be their credit cards, fifth will be their maybe their mutual funds if they're going to allow. Then they have the other services like loans. In loans we have three types of personal loans, banking, car loans, home loans, gold loans. So these are called the sub entities of entities.
Mm-hmm.
So before creating a ER diagram or before creating a data model for any system, first things we need to consider is what are different entities we can extract from that system. Okay.
Mm-hmm.
And second thing will be how the entities are going to relate to each other.
Mm-hmm.
Because ultimately, what are our last objective? The last objective is how we are going to create a database. And every database must be in a must follow the concept of RDBMS or a concept of fact and dimensions.
Mm-hmm.
Correct?
Yep.
So so you must have to keep in mind if you are going to create a fact table or going to create a dimensions table, so all the tables should be relate to each other or having a concept of referential integrity.
Mm-hmm.
Or if you're going to create a tables and a database in RDBMS, it must follow the properties of primary key and foreign key relationship.
Yeah. Mm, that's right.
Yes, yes. So when you're going to create a ER model or when you're going to create a data model of any system, you must have to keep in mind the entities of that system should relate to each other. But in general life, uh, in live scenario, it will not be happen. As a data modeler, you have to think about the entities. You have to define the relationship of the other entities and then create a data model.
Mm-hmm.
You got my point?
Yep.
It's, so you have, because the main objective of data model is same. We have to think about the entities. So if we talk about in live scenarios, what are the objective of a data modeler? The first objective of a data modeler is to understand the system very clearly. So every inputs and output you must have to know,
Mm-hmm.
because your inputs and the suggestions will help the developers, will help the architect role, will help the database or visualizations developers also. So they are good because they will not do anything in creating a data model, because they are the different teams and you are just leading the team of as a SME, as a data modeler, so that you are going to support a data engineering team, you're going to support a database development team, and you're going to support a data visualizations team.
Mm-hmm.
Why you are going to support a data visualizations team and all those things? Because the role is just like a data modeler. Then a modeler need to interact with the data engineers, need to interact with the database developers, and also need to interact with a data visualizations team,
Mm-hmm.
because they are going to only use the views. They're going to
Yep.
only use a they're going to only use a extracted data that they're going to extract with from the database, and who
Yeah.
will the data, a database developer,
Mm-hmm.
either in forms of some scripts or in secure view. Okay, one thing you know about the views.
Yeah,
Yes.
just like,
So
yep, that's right.
so basically what happened when you go for a cloud data model or a data modeler in terms of Snowflake, Azure, AWS, and all those things. So we have two things. First, we're going to create a uh, view, and we are going to uh, send send it means transfer the record sets in terms of a view, and that view is called our secure view. SV underscore, the naming convention should be like this. Why we are going to say secure view, that is I'm just giving. So as a data modeler, when you have designing a database, when we have designed the tables, all those things we have done, and same thing has been created by your database development team. So some tables, some mapping, and all those things. Now as a third party of the system or a output, you are going to create a view on each visualizations report, so that all the views will be used by the data analytics team. So they are going to visualize the data, but which data that you are sending to that team. So if the model will be not perfect, the output will be also not perfect. So that's why all those responsibilities and ownership comes into a data model.
Mm-hmm.
And this is the main and essential part of any of the system nowadays, because the system and the requirement changed in recent 5 to 6 years. They are not stick with the design, and they are not stick with the developers. They have a one level up approach as a data modeler.
Mm-hmm.
So so you the first main objective is to know the business properly. Second point, to create a data model that should be flexible. Okay. And
Mm-hmm.
third, so every process data, either structured and unstructured, should be ingest by the tables properly. It means there is no gap or missing data word comes after the processing.
Mm-hmm.
So only these three things we need to consider before creating a data model. First thing, to know the business process well. What we have done in the second thing
Business process and then the relationships, modules, and their functionality.
is, so first things, business process, the modules and the functionalities. Second part
Uh, how the uh, how the modules are related to each other, right?
is, we need to uh, find the relationship between the modules and the entities so that we can create a model. And third part is the data model should be flexible so that
Mm-hmm.
it can be expanded at any time. It means, suppose as a data modeler, you have created a data model for the banking domain, and on that time there is no mutual funds and loans facilities available on that bank. It may be happen because uh, the system has recently started, they are just doing a transaction in terms of saving account, current account, and that's it, only two accounts are there. But later when the bank grow, he thinks, no, now I am capable to give loan to the customer. So you must have, your system should be, your the model should be in such a way so new models can be integrated into the existing model.
Mm-hmm.
Okay. So when it will be happen? It will be happen when your data model should be flexible. When your data model will be flexible.
Yep. Mm-hmm.
Okay. And always we have to think about the flexible data model.
Mm-hmm.
We know nowadays requirement is not changing day by day, but the enhancement come anytime because as a software company employee, you know when enhancement comes, the customer has to pay.
Mm-hmm.
If customer is going to pay to enhance their functionalities, then you must have to enhance your model also.
Yeah.
Yes. So the business process attributes their models and the functionality is the first part. Second things, as a logical data model, you must have to think about the relationships. And third, it should be flexible. So
Mm-hmm.
these things must have to keep in mind before creating a data model.
Yeah.
Okay. Physical, you're going to create a blueprint of the system. You are just thinking, okay, so there will be model and that model is going to relate with the others and so on. You are thinking in this way. Okay. So the second part is the logical that we already have discussed, in which we are going to discuss all technical stuffs like the data, attributes, relationship, constants, subtypes and subtypes, and how we are going to manage the data in one database system or more than one database system. So all things of technical discussions that will be happen during logical data model.
Mm-hmm.
But the logical data model will be discussed within the team, not with the customer,
Mm-hmm.
because we are going to actually implement the data model. Okay, so how the logic has been, what you are going to ask with the customer, you are going to ask the functionality of a module from a customer. Hey, why you have created this page? It means, suppose you go to, sorry, suppose your requirement manager or you uh, attend a meeting with the customer and they have shown a form. Hey, this is the form we have prepared for the customer. Okay, we have gone through the forms having few columns. Then the question should be, hey, why, what is the functionality of the forms, what you are doing with this forms, and which types of input you are taking from this form as a user in manual system. Okay,
Mm-hmm.
or if you got some data or some feeds, you know the word feeds
Mm-hmm.
is feeds in.
Ingestion.
Yes, feeds in terms of some JSON data, some text file, some Excel file, CSV file, any a number of things. Okay,
Mm-hmm.
so
Mm-hmm.
if you got a feed, then you must have to relate first, go through the feeds and all those things, and then define your logical model. And when the logical model will be finalized, a conceptual model will be a big feature of view systems and will be the actual implementation within the database.
Mm-hmm.
Okay, so always remember we have two things. Two things means a dimensional modeling. In a dimensional modeling, we have three types of data model: physical data model, logical data model, and conceptual data model. Okay,
Mm-hmm.
a data model and data analytics. These two terms are related to each other. I'm again repeating my words. A data modeling and a data analytics, because a modeling helps to create a better visualizations for the stakeholders, for the customers, for the senior managements, and all those things. It totally depends upon a data modeler. So how he is going to create a model so that it helps the data visualizations team or a data and analytics team, and that
Mm-hmm.
we term BI, business intelligence. So you heard about the BI tools of Microsoft, SSIS, SSAS, SSRS.
Mm-hmm. Yep.
So what we do in this? We do the same thing data modeling and data analytics. SSIS, SQL Server Integration Services. SSRS, reporting services. SSAS, analytical services. Okay. So all those reporting tool, Power BI, you know about the Power BI?
Yeah.
Is Tableau.
Mm-hmm.
So what we do in this, we create a data analytics, a data visualizations report to showcase the customer.
Mm-hmm.
But a data model helps the analyst to visualize a data sets in better insights. And these terms that we have written the related is data integrity, data analytics, structured, unstructured, business intelligence, all comes as a part of data modeling.
Mm-hmm. Yep.
Okay?
Yeah.
Because you have to think structured as well as unstructured data also. So I'm going to add one term. When we have an unstructured data, uh, then we have data transformation is needed. So when we have a unstructured data, then the data transformation is needed.
Mm-hmm.
What my point?
How just like to bring it from unstructured to structured or to fit into the database?
Yes. So data transformation in terms of what? Data transformations in terms of a simple example I'm giving. Suppose we are getting the date time stamp from the source.
Mm-hmm.
Okay. But our need is not to get the time. It may be, we are stick with the date, we are stick with the month and year. So here the transformation is needed.
Mm-hmm.
Okay, first. Second, for a system, suppose if we are getting a customer name, so the transformation should be like this: first name, middle name, and last name. We are going to extract from that name. Okay, so these are the example of transformations. Just a basic examples. I'm not saying that because a lot of types of transformations happen during a ETL process.
Mm-hmm.
Okay, like date transformations, lookup transformations, then we have like combined together, then we have a lot of transformations, combinations, then we have a lookup, then we have a cleanup process also comes during the transformations. So all those processes are going to clean and going to prepare a data from unstructured to structured.
Mm-hmm.
So that's why in a system we are going to use a staging table or a raw table. Okay. So when you use, okay, one question. So which tool you are going to use as a data modeling?
Arvind.
Admin, okay. Okay, that's fine. So Admin is the best tool in the market currently. Admin, Oracle Data Modeler. So these two are the best, but most of the company are going to use the Admin because they have a lot of functionalities. So how they're going to use, they're going to maintain the historical parts also, and so on. Okay. So suppose you have created a model today. You're going to create a data model and later sometime you're going to change. So you can also see the differences and what we have done changes by tomorrow.
Mm-hmm.
Okay. So, so these are the terms: data integrity, data analytics, structured data transformations, often structured data, business intelligence, that is also known as the BI part, is related to our data modeling.
Yep.
Now, we have two types of data modeling technique. First is the entity relationship and second is the UML. Okay. So when it comes about the OOPS concepts, object-oriented programming structure, so we have UML. UML is called Unified Modeling Language, but it is not a language. It is just to draw a diagram in terms of class diagram, object diagram. Then we have use case diagram, process flow diagrams. Uh, then we have state chart diagrams and so on. So these diagrams comes under our UML part. But in
Mm-hmm.
a data model, if we talk about ER model, that is called the entity relationship model, so that covers our physical model, conceptual and logical model part.
Mm-hmm.
So data model basically what we do. It's organize the data descriptions, data semantics, and the consistency constants of data throughout the system.
Yep. Mm-hmm.
So you heard about the SCD?
Yep.
Yes. Okay. Sorry. So SCD plays an important role while designing your actual database
Mm-hmm.
and all types of SCD. So SCD 1, 2, 0 is not sometimes used or not. I will explain with one example of SCD also. So the slowly changing dimensions plays an important role in terms of data modeling when you're going to design our physical data model.
Mm-hmm.
So why physical data model? Sorry, why SCD plays an important role? Because
Yeah.
SCD have types. Okay,
Mm-hmm.
you've also gone through type 0, type 1, type 2, type 3, and so on. So I will explain with one example every type when we will discuss this topic. SCD plays an important role in our data modeling when we are going to create the actual databases. It means physical data model.
Mm-hmm.
So always clear. Conceptual, it's a blueprint. Logically, it means we are going to relate the attributes and their modules. And physically, it means the actual database we are going to create within the system.
Mm-hmm.
Okay. So in STD, it's plays important role. It's give a sense to a data modeler to create their columns like audit columns, you know.
Yep. Just like load date, timestamp, start time, and time, right? Delete flag.
Yes, correct, good. So audit flags means your load date and times, your create date, created by, update date, updated by, and users from which system we are going to update those things so that it can be used later. If any queries will come, hey, who has updated this values? So if a audit columns you have within a tables so that you can so know this column has been updated by a API, by a manual update, by a user, and so on.
Mm-hmm.
So audit column is really needed.
Mm-hmm. Yep.
So the SCD give a sense. So when you're going to create a data model, a physical data models, not data model, a physical data models in terms of actual tables, rows, columns, and so on. So the SCD gives suggestions to implement within their table architecture and so on. Okay.
Yep.
Yes. So Going forward, yes. So why we use a data model? So these are the types. You can go through it, no issue. This is not needed to go one by one.
Mm-hmm.
So, so data model goals ensures data objects, a help in design database, data model structure. Then we have a clear picture of a base tables, identify the missing and the redundant data. Then we have the initial creation of data models and so on. That is the main objective.
Yeah.
So now we have this thing. So see here, a logical model, physical model, and create a database and so on. So in logical model, we think about the process and the data requirements.
Mm-hmm.
Physical data models, technical requirements, what we receive that we are going to convert.
Yep.
So what, how, and how we are going to manage, that is our person. So every time when you do or when you involve into a requirement gathering process, so when client is going to explain the process, he will give some facts to you. Facts in sense, suppose he will say, hey, this is our system and we want to enhance our model. Currently, it is not going to follow any models. It's just a uh, mm, SQL Server databases or Oracle databases having some tables and views. But now the system is too big. We are not going to fetch different types of reports from the system, or we are not going to optimize our data so that it can be utilized in visualizations. So in such scenarios, a data modeler or data modeling is needed
Mm-hmm.
because owner of the system, because the stakeholder of the system is not going to see the data, they're going to see the graph.
Yep.
Yes. Any of the enterprises or a company, even a small company, like if we talk about Ola Cabs, if we talk about the Zomato, Swiggy, these are the company and not a huge company, but the owner also is not going to see the data sets, they're going to see the visualizations. And when
Yep.
a data visualizations comes into the picture, we need a data model.
Mm-hmm.
I'm not I'm not saying that we can't create a data model. Sorry, we can't create a data visualizations from a database. We can create, obviously, we can create through the SQL scripts that we are going to apply on databases and can create a report. But it can create some problems also later when we have multiple data sets or resources coming to integrate into the existing model.
Mm-hmm.
So there are two things happen. Either you will work on an existing system to create a data models to enhance their visualizations, to enhance their data points, and so on. Either or you will create a data model for a new system.
Mm-hmm.
Obviously, uh, so if there is a existing system and from the existing system you are going to create a data model, so that will help you because you
Mm-hmm.
know you're seeing how the existing system is running, how the flows has been created, what are the process flow of that system. So you are seeing within the tables and a data flow. But if a new system uh, has come and you need to create a data model, then you have to give 120 to 25% of your task. But for existing system, 100% is fine. Why I am
Mm-hmm.
saying this percentage or a task, because I have worked on both types of system. Okay, so you know the AT&T clients,
Mm-hmm.
AT&T and AT&T or Walmart or any. So Walmart, what I have in life, have a huge set of data, and their
Mm-hmm.
source system is also 10 to 15 source system from
Mm-hmm.
where we need to extract the data. we need to pull the data in our system, and then we need to create a data models for one part only, and that is the uh, sales and uh, manufacture graph. That is the one part of Walmart we have worked for in COVID times. Okay, for from our side, it means from our company, and only one part of Walmart having a huge set of data.
Mm-hmm.
So, and one example. So a bank having a review and comment system. It means if any customer comes, he wants to capture the feedback from the customer. So similar to a e-commerce also, when you're going to purchase, a message comes to you. So how you're going to rate the process in 1 to 5 and give some comments. It generally happen. So they're going to capture the review comments and ratings from four different sources, from the API, from the mobile app, from the website links, and from the flat files that is coming
Mm-hmm.
as a receipt. Similar to a banking system also, if a bank wants to take reviews from the customer, so he has created some uh, reviews as a comments and ratings. So for one data points, the data was, I've just told four sources as
Mm-hmm.
an example. But think about the uh, other sources also. Suppose your banking system had done uh, what I'm saying, digital marketing. Okay,
Mm-hmm.
and from that digital marketing, you have a Facebook page, you have a Instagram, you have a Twitter, or any of the pages, LinkedIn also. And so from where you're also going to capture the comments. So your data point or data source will be different.
Mm-hmm.
As a simple system, we also have to think, so what are different sources we're getting and how we're going to manage. And all those data are coming from APIs. Some data are coming from mobile APIs. Some data are coming from Google Sheets. Some data are coming from scheduled job, and so on. Some data are coming from flat files. So to create a system, you must have to, I'm talking about the inner one. Inner one, it means the logical part. Conceptual, we have done, you know the process, all those things. Logical relationship also done. Now, when we are going to create a physical data model, that is the actual table, then you have to think about the keys. Keys, it means in terms of primary keys and foreign keys. But here in data model, the keys will be hub key, or the super key, or surrogate key, or any keys that you're going to create in your admin, that will be unique.
Mm-hmm.
So one scenario, suppose uh, you have customer data that is coming from three different systems. Just an example, one has uh, opened a startup in 2000. Okay, and on that time the company having not too much fund to expand, and he has taken Microsoft license on that time.
Mm-hmm.
Okay, so here used to capture the data in Excels and Microsoft Access,
Mm-hmm.
because Access and Microsoft Excel on that time, because company was not too big, um, they don't want to purchase a license version and all those things. Suppose he grew up sometimes and he has purchased SQL Server license, Microsoft SQL Server license. Now the data is in SQL Server. Again, now the company grow. he has purchased Oracle licenses. Okay, why he wants Oracle? Because from the Oracle he also get the license for the enterprise.
Mm-hmm.
Now, company is too big, having multiple zones, having multiple modules like the manufacturing sections, HR, admin, sales, pre-sales, all those things. He want to shift the data into a cloud, into a cloud like the AWS, Azure, Snowflake, GCP, and all, and any of the systems. So, and now you are a data modeler.
Mm-hmm.
Data modeler, you need to create a data model. Okay. So think about the system. The first data was in XLMS access that is used for some time. The data is transferred into the SQL server, now in Oracle. Now you want to create a system, a data model to capture all those data to see is the company from 2000 year to 2023 how the wings are going on. Wings, it means how the sales is working, how the manufacturing is working, how the production is working, how the HR, admin, employee, all are working perfectly or not. He wants to see the graph.
Mm-hmm.
So, how much he has expanded from their revenue as well as from his stakeholders, and what are the benefits of that? Because companies
Mm-hmm.
now having an aging of 20 years, and he wants to see the uh, progress, he wants to see the insights of every module. So as a data modeler, you must have to think, hey, the data in different forms. It may be Excel having also an ID of 101. It may be possibilities SQL Server having also an ID of 101. And Oracle also have been created an ID of 10. It may be possibilities. So
Mm-hmm.
while designing a database of a staging server, sorry, a raw table or a staging table, you have to keep word on ID. It means create a either a identity columns or a hub key so that it can differentiate those IDs with your unique IDs.
Mm-hmm.
Because Excel having 101, SQL Server also having 101, Oracle also having 101. For their data sets, both sorry, all 101 is different.
Mm-hmm.
But for you, when you are going to drive the data, so you will face some problem with 101. So while creating a data warehouse or any of the system, you must have to create a super key, hub key, private key, any of the keys of your own system. But
Okay.
the ref
Mm-hmm.
but the references would be there.
Yep.
Okay. So these are the same diagrams of data model, conceptual. This is the logical and physical. And we have this. So I'm going to conclude the class now. Is it fine?
Yeah, that's fine. Mm-hmm.
Okay. And all those topics that we are writing here will be also discussed. Because when you're going to discuss something, then something comes between this, like SCD, DFD, transitive dependency, star schemas, factor dimensions tables, and then we'll also cover some parts of your admin. So how you are doing this, how you are doing the actual implementations. If any help needed from my side, then we can discuss.
Mm-hmm.
Okay.
Yep. Sure. Thank you. Thanks for that. Yeah. Thank you.
Online transactional processing system. Online transactional. What is transactional? Transactional means which is going on, which is ongoing, which is live, which is working, which is functional or operational. Okay. Generally, the live system, the live application is called as transactional processing system. Okay. Here, the data is live. When we say live, how many months or days or years of data is stored in the system? Okay, so whenever we say OLTP, it's a database. Basically, database means what? It is built on data model. Data model is built using normalization, correct? So
Yeah.
where you have master table and child table concept, correct, with foreign key, primary key, all the relationships. So basically this is database. Whenever we say database, it will not have the history data. I mean, not all the history data. It will have the history data of some time based on the business requirement, but not all the history data of business. Okay, so if you want, I'll just, you might definitely know about how your data warehouse works. Let's say you have a business, okay, and your business is across the locations. Okay, your business is across the locations.
Hmm.
So here you are using one database. Let's say it is city, you go for Oracle database. In the towns, you go for one more database. In villages, you require less cost because the number of customers are very less. You don't want to invest much. You go for MS Access, which is part of your already employees toolkit. Correct? MS Office is compulsory for every employee, and you are not investing on any extra database. You go for MS Access as a number of customers in that particular area is less. Okay, and what you are doing is at the end of the day you are going to integrate all this data from different systems, and you are going to keep in one system, and you call the system as ODS. This also one database only. What is this ODS about is, that's also operational data only, OLTP only. This is called as operational data store, all the operational data at one place. Okay,
Yeah.
let me know if you feel something you know and it is boring. Okay, any point of time if you feel bored, you'll please let me know. So this is operational data at one store. So here this operations data is prepared by pulling up, by extracting the data and getting loaded into this. If there are any transformations, this is done by ETL tools. It is not our work. Okay, maybe as a data warehouse person you might know that. Finally, if you want any report, let's say the business is very new business. If you want any report, you can get from either of the systems, either this or this, based on your need, by writing some SQL procedures or SQL content, right?
Yeah.
Yeah. Okay. So now till here you are good. Now system is new, your business is new, you have very less data, very less number of transactions. So this is working fine. But over a couple of years, the performance of your reports may go down, due to which your transactions, because your transactions are more. Your transactions are more means your customers are more. When customers are more, transactions will be definitely high. To overcome this, what you do is, or what generally architect does is, introduce a concept called as data warehouse. Correct?
Yeah.
Data warehouse is the one where you are going to store history data. What about here? You'll keep a business rule. If data is greater than 30 days, if data is greater than or equal to 30 days or 30 days, you move the data from here to here. Again, ETL jobs are developed to pull the data on a condition if data is greater than 30 days. Example, today is 8th February. So today it will get the data which is minus 30 days, means last month 8th data will be loaded here. Every day this is scheduled, so that every day it will check any data which is greater than 30 days and it will load the data into data warehouse. So due to which your database performs better for the reports which are pointing to your database. Okay. But now for your data warehouse also, if you want to work with the older reports, your accounts statement, which is of last 2 years, you want account statement of last 2 years. When you are applying for a loan, they may ask your account statement of last 5 years also. So then you need to pull the data from data warehouse. Again, you write SQL and procedures or SQL queries, you get the data. Are you clear?
Yes.
So reports can point to your database or reports can point to your data warehouse. These systems are called as OLTP system. This system and this system are called as OLTP system. And this system is called as OLAP system or OLAP system. What is that? We'll see later. Still, later after a few years. Let's say this is 2 years. I said. Let's say 10 years after. After 10 years, you have, let's say, 100 plus reports are there where they are performing low. To overcome this, of course, you are pointing to data warehouse. Still, the performance of these reports are bad. To overcome this, what we do as an architect is we introduce a concept called as cube databases, multiple cube databases, having a slice of your data from data warehouse. And it's a multi-dimensional database so that the performance will be better. Okay. You can have one more cube also. It depends on the need. You can have multiple cube databases. Nothing wrong in it. It depends on the requirement. Okay. You connect to this. With the help of analytical tools, you develop these cubes. And from here also, you can get your reports. You know this?
Yes.
So here, analytical tools play the role, like OBAEE, SSAS, MicroStrategy, such tools, which will get data from your data warehouse and load the data to Cube database. From Cube database, again, you use a reporting tool. Here also you can use reporting tool. Here also you are using reporting tool to get the data from your databases. So this is you do. Now reporting tool can be a reporting tool like a Crystal report or a Cognos report or SSRS, or it can be a Power BI or Tableau dashboarding tools. Okay,
Yeah.
clear?
Yes.
This process is called as data warehouse lifecycle or business intelligence lifecycle. Okay, and every team or being though you are a data warehouse resource, you may not work on all this cycle. You may work on ETL side, or you may work on the reporting side, or you may work on this area, or any combinations. Okay, having everything in one project is not so easy. It is divided into small projects to multiple teams. Okay.
Yeah.
Okay, now here cubes are called as OLAP cubes or OLAP databases. OLAP cube. And this OLAP is further divided into multiple types. OLAP is further divided into multiple types. MOLAP, ROLAP, HOLAP. You know all this?
Yeah, I've heard about it, but don't remember
Okay.
the
I'll
definition.
tell you how this works also if you want. How the background principle. What is the principle of working each type? Okay. Because it will be definitely part of your interview questions. OLAP and types of OLAPs are part of your interview questions generally. Okay, on the data warehouse side. Okay, so coming back here, you got the life cycle, you got the ODS. So here, basically, you are dealing with the transactional data. Okay, so whenever you say transactional data, it is ongoing data. So here, you store only the data of recent information, not everything. Okay, see here, OLAP system refers to database. It's a system where time sensitive transaction related data is processed immediately. Your requirement, your question is answered immediately, and always data is live data. Okay.
Yeah.
Example, let's say you are going to bank, to deposit some amount. What you do? You start from your home, you reach the bank, you fill the form, you wait in the queue, and then you reach the teller. Once you reach the teller, you are going to give the form and some cash to deposit into your account. Okay, and it will take less than 2 minutes. They just check, enter, stamp, and give you the receipt, acknowledgement receipt, saying that money is deposited. Within a minute, you'll get SMS saying that so and so money got deposited. Yes or no?
Yeah.
How much time it has taken to deposit money into your account? it just taken less than 2 minutes. We cannot consider the time you started from your home. Once you have given the slip to your teller, from that time you have to count. It will be less than 2 minutes to complete a transaction. Yes or no?
Yes.
The same way you take withdrawing money from ATM, the same way you take booking a product from Amazon or Flipkart. Don't consider the amount of time you search for the product. You just consider the time. Just consider the time you have placed an order. Once you place an order, submitting that net banking option and completing the transaction, it will take less than 2 minutes to complete the transaction if you verified it or not earlier. Okay. So any transaction you say, it takes less than 2 minutes. Correct? That is called
Yeah.
as OLTP system. OLTP system, it is going to process your request immediately, and always the transactions are live transactions. Okay.
Yeah.
Example, I already gave a couple of examples. You consider any example that is going to be taking 2 minutes of time to complete the transaction. Okay. That is
Yeah.
collapse OLTP system. Now coming to OLAP system. Okay, OLAP system, online analytical processing system. Online analytical processing system. What is this online analytical processing system? The name only says analytical. Analytical means you need to perform analysis. Analysis, analysis usually where we do on lot of values. When you have huge values of data, then you start analyzing. Correct?
Yes.
Yes or no? So
Yeah.
when you have huge volumes of data, then we need to do the analysis in order to understand it and to take some decision or present it. Okay.
અરે પણ સારા માટે છે ને કે ભાઈ તમને એવું ના થાય વધારે તકલીફ થોડો પોઝિટિવ.
So OLAP, we need to do analysis. When you say analysis, it is going to take time. Correct?
Yes.
It is going to take time. When you take time, when it takes time, the results are delayed. Okay. To make this faster, we are following these approaches. So not only these approaches, whenever you follow any approach, definitely it will take time. Example, you need last 10 years transaction from your bank statement. Okay, of your bank statement from your bank. You don't have an option to get it online. What you need to do? You need to consult bank. When you consult bank, what they do? Call customer. You are going to call the customer care. You are going to raise a request. Yes.
Yes.
When you raise a request, what happens? They take your details, okay, and they say it will take 5 working days to deliver. Why 5 working days to deliver a statement of mine? Because the ticket who has been created will be given to some other person who will review and assigned to some other person who will work. And once the work is done, the work has to be queried across all the customers, across all the branches, and retrieve only your data from whole warehouse of last 10 years. And then once the report is prepared, it has to be given to a person who will review. And once it is reviewed, he'll give to some person who will be mailing you. Okay.
Yeah.
So this process will take, let's say, 2-3 days, and your retrieval of data also takes some hours. Okay. So to be on safe side, because you not only you are requesting, there are many people have multiple requests across with the data with the backend team where they have to consider all that. So your sequence, though it takes 2 to 3 days of time, but your turn comes before other people's turn is done. Correct? To
Yeah.
be on safe side, the system says 5 working days, even though it is taking 2 days. But 2 days is also not immediate. It is taking time to get your result. Yes or no?
Yes.
Any system which takes time to respond your request more than hours or minutes, then it is OLAP system. Okay. See here, what is the purpose of doing analysis? To make better decisions. Okay. Software that allows user to interact with a very large online system and request and receive response practically in a desired format. Okay. Or in a report, whatever the way style you want. This will take a lot of time. Okay. Here, if you want to take a decision, I'll just mute yourself. You can mute yourself. Let's say if you want to take a decision based on a news, what you do, you are going to do R&D and then take a decision. So if you know about trading, you are simply not going to buy something based on someone words. You are going to do some R&D, correct? Not only that, if you want to buy any product today, if you want to buy a mobile, you are going to take a lot of time to decide. It is not simply you just go and click. You are going to understand what are the features, what are the versions, what are the models, what are the companies, what are the brands, reliable, durability, cost. All these things you are going to analyze and go for a decision making. So this all analysis takes time. This all analysis takes time. Okay. If you work with warehouse, if you work with historical data, which is going to complete in hours or days, okay, that system is called as OLAP system. Okay, are you clear?
Yes.
Okay, you can take any example. I told couple of examples. So these are all time taking systems. That's why it is called as OLAP systems. So before stepping into the next step, which is not part of this, that's the reason actually I have drawn this. This OLAP is categorized into three types, that is MOLAP, ROLAP, MOLAP, ROLAP, HOLAP. MOLAP is called as multi-dimensional OLAP, ROLAP called as a relational OLAP, and HOLAP called as hierarchical OLAP. Okay, what are this? We'll discuss today because these are not part of notes. When the concept of OLAP came, when introduced with warehouse, the concept of OLAP came. So, and then you are introducing this concept, cube database. So when you introduce concept of cube, okay, how it works, I'm going to say. So let's say this is your analytical tool like OBAW or SSAS. This is your analytical tool. This is your data warehouse. This is your cube database. Okay. So what is the use of coming to cube is to improve the performance of your data reading in the reports. Then so here whenever you say here data is getting from here to here, because data warehouse source is, sorry, cube source is data warehouse, so it has to read the data from here, it has to load the data to here, and from there you'll get the report. Okay, so now what is the type of OLAP you selected for this approach? OLAP approach, whether it is MOLAP or ROLAP. HOLAP we don't use, that's a hybrid OLAP, mix of both features. So what is envelope or lap? What are the rules? If we see, then we get to know which to use. Let's say when I say envelope, what happens? Let's say this is envelope. Whenever I say envelope, the system is of envelope. It will read the data from here. It will load the data to here. It will create the indexes. It will create the aggregations on top of the cube so that you'll get the better performance. Okay, I type it here. Please stop me if you don't understand or if you feel again this is out of the content. Basically, as you said interviews, I'm giving all this. Okay, actually this I don't cover in usually. Okay, one is read data from data warehouse or underlying database, load data to cube database, creates aggregations. There is a concept called as process that will do this. Okay, create aggregations at cube database level, create aggregations and indexes at cube database level in order to get the better performance. What are the advantages is you get high performance or better performance in reading your data from the cube. Disadvantage is not live data. Okay, so here there is a step called as process. There is a process option as a process click. Whenever you click on this process button at your analytical tool, okay, it is going to do this job and then load. If you don't click this process, if you don't process your data, these 1 2 3 steps are not executed. 1 2 3 4 steps are not executed. Okay, so you don't get the live data, it is old data only. That is one disadvantage with envelope. What is next one is ROLAP. What is ROLAP? Just a second. Just a second, I need to plug the charger.
Hello, Venkat. You're on mute or? I'm not able to hear you.
Now able to hear me?
Yes.
Now? Okay,
Yes,
I'm
yes.
going to repeat it. I'm going to repeat it, no problem. So ROLAP, okay. Okay, ROLAP. RLab, what it will do is it is going to read the data from data warehouse. Okay, it is going to read the data from data warehouse. It is going to load only the structure, not the data. It is going to load the structure. So here we are going to design the model. We are going to design the cube model, not the dimension model. We are going to design the cube model. What are the tables are going to come accordingly based on the model? What required tables are required, structure required from this underlying data source, it is going to move. Only structure is moved, not data. And it is going to create the indexes on the relational database, that is data warehouse. This is also relational only, right, basically. And it is going to create the indexes and aggregations which are required at your relational level, which it is going to design at relational level. Okay, now what are the advantages and disadvantages? Let us see. So what happens here is in the envelope, okay, I'm back to envelope. Here whenever we request data from the cube, we write MDX expressions, multi-dimensional expressions. Okay, we write MDX expressions because this is already multi-dimensional data. It is going to read the data and give the data to you based on your input. Okay, now coming back to ROLAP, RLAP, you have given one requirement. Okay, I want some data. You are giving in MDX format. The data is not here, only structure is here in the multidimensional format. So it is going to read your data and send that request to underlying database. And then accordingly, here before sending, it is going to convert your MDX format to SQL format and send that request to data warehouse. Here your request is processed and you are going to get data. You are going to get data in the two-dimensional format, and once it comes, it is going to convert to multi-dimensional format and it is going to present to you. Okay, so here your multi-dimensional format to two-dimensional format, two-dimensional format to multi-dimensional format. This conversion, and from relational to relational format, it has to display here. Okay, query conversion, data conversion, text out of type on top of the traffic. This sits somewhere, this is somewhere, let's say, or even in the same server also, it is going to take time to get you the data. Yes or no? You got the point?
Yeah.
Okay. So because of that, it performs. What are the points here? When we have a process option, whenever we click on process, what it is going to do? It reads data from data warehouse, loads only structure or copies only structure to cube database, indexes and aggregations are created at data warehouse level. Okay, due to which, what are the advantages? It is live, always you get the live data. Okay, advantage is live data, but the problem is performance issues. So because of the performance issues only, we are coming to cube database. If you are having those still performance issues, what is the use of coming here? Client does not wait for you to get such time to pull and give in the report. Client won't wait. So what is the solution? Solution is go with Envolab, but it is not live. Don't worry. This process option, do it on your intervals on daily basis or 12 hours basis or hourly basis based on the need. You can refresh, so you can schedule this, not a manual one. You can even schedule this option so that every 2 hours, every 3 hours you can schedule. It keeps pulling the live data and keep in your cube database. So such how you can, in that way you can get the latest data and best performance output. Are you clear with this?
Yes.
For sure it is going to be interview question, MLAP, RLAP. Usually it is an interview question for any data warehouse resource. So you can make note of steps. If you have any questions now or later, please ask me. Any other questions till now?
No.
Okay, so you know about OLAP, OLTP, ODS, RLAP, and even the life cycle, data warehouse or business intelligence life cycle, correct?
Yeah.
So you can go through here. OLTP is explained, OLTP and OLTP both explained, and the life cycle thing. You asked about the nodes, you remember?
Yeah.
Today I share the nodes, okay? Today I'll share the nodes. So this is about intro part, okay? Now I need to cover some normalization concepts. Shall I go with that?
Yeah, sure.
Okay, just a moment. Okay, now we discussed about yesterday forward approach. Forward approach means designing your data model from scratch if you got requirement, correct?
Yes.
Designing your data model from scratch, you know that. But let's
Yeah.
say if you have a data model already, or if you have a database existing already, you have a project already running, and if you want to do some changes to it, how? Just think, you have a house already. What is the approach? See, you have a house and you need some changes to the house, correct? That is a requirement. Already you have a house, you need some changes to the house. So what you do, you are going to identify the changes. So when you identify the changes, there are two things. Point number one, when you go to the civil architect, do you have already blueprint? Yes or no? The first
Yeah.
question civil architect is going to ask is, do you have already existing blueprint? Yes, sir. Then give that. He will take that. He'll make a copy. He'll do the modifications on top of it. Okay. Point number two. Answer is no. Answer is no. Then he comes to your house. Okay. He comes to your house, take the measurements, and then prepare a blueprint. First he is going to prepare the blueprint for the existing house. Then he'll take another copy of that and then do the changes based on your requirement. Alteration requirements. Okay. Agree with me?
Yes.
So this is a technical way I'm saying. Okay. Generally, you may go with your approach. Generally is we consult a civil architect. He takes the blueprint as a source, and what is there, what is required, he is going to measure fits or not fits, whether it fits, whether it is going to exact fit or it is going to again compromising in the requirements. He is going to do that analysis and get you a blueprint. Okay. When you say there is no blueprint, he has to come to your house, he has to take the measurements of the existing house, then consider your requirements and then suggest the alterations to the existing blueprint. He is going to give the latest blueprint. Accordingly, you can go with the construction team to alter your house, right?
Yeah.
Yes. Okay. Next, coming to database. So I told this is a house. This is an approach. Coming to database, what will be the approach? So let's say you have a database. What is the approach? Already there is a database which is in the market or which is running. Your project is already running. What is your approach for this? Same steps. First, let's say this project came from company X to me. Okay. Earlier, the client was with X company, and they gave it that what is that called? Agreement is completed, and then bid happened, and it came to my company. So in this cycle, there are some performance issues, or there are some other issues which led to the database model changes. So then, what is the first thing architect do is, do you have the data model for the existing database? First question. Same like how. If answer is yes, take it, open using data modeling tools. Okay. Design the add-ons. Okay. Design the add-ons and create a new database. So there are, let's say you have added some 20 tables in the new design. So then ask the developers to take the 20 tables only script, generate that script for those 20 tables, or while generating only you can select those script and you can give that script to them. Okay, to create that in the new database. But whenever you go to new already existing system means it is very difficult. Okay, you should not disturb, you have to copy the existing system database and you need to take out the new 10 tables which you prepared along with the existing, and you need to fit it. When you do fitting, there are changes to the existing tables also, so you have to ensure that there is no any changes or there is no any problem to the existing database. For that, what you need to do, you need to tell the developer this data, this table is getting extended with 4 more columns. This 4 more columns data to be populated based on some transformation logic, you need to consult with business analyst. So they will give all this required documents to prepare and load it. Once this is tested successfully in dev test environments or whatever other environments, then it will be released into the production. You got me right?
Yes.
Okay, you know all those steps. So only here is you are adding additional tables, additional procs, additional scripts to existing database. Okay, next, if there is data model, this is approach, else no data model existing, because this is a project which is running from last 10 years and this is coming from different company, and we have upgraded in between from SQL Server 8 to SQL Server 2014, and I don't have the data model also. What to do? Existing database, no problem. Again use data modeling tool, generate, not create, generate data model for the existing database. Okay, and follow step 1. That's all. Okay, got it?
Yes.
You are going to generate the data model. No, this is not a, see, this is not going to time take. This step, whatever I told, looks maybe something big, but actually this is very easy. The 2 steps are very easy. If it is already existing, of course adding on will be difficult. We need to do a lot of analysis, but getting the data model, initial data model, which is existing system, if even though it is not there, you can get it easily from the tools. Okay, this approach whatever we are discussing is called as reverse engineering approach. Yesterday whatever we discussed is a forward engineering approach. Whatever we discuss now is a reverse engineering approach. We are going to see this approach also. Once create a data model, if you need any changes, what you are going to do. Okay,
Yeah.
so that is explained here actually. Yeah, forward engineer, it's also called as the top down approach, or reverse engineer called as bottom approach. When we have an existing model and a database, then we do changes to the existing model with the given requirements. When we don't have existing data model but we have database, then we need to extract the model from the existing database using the Erwin tool or ER model tool, and then do the remodel. Okay, same things I told here.
Yeah.
Okay, any questions till now?
No.
Okay, shall I continue or shall I stop?
Yeah, as you wish. You have time, you can continue.
Okay, so we'll continue. Let me continue for a few more minutes. Okay, so next information, this thing, then constraints we need to start. Okay, I'll discuss about, because this I'll do very fastly. Okay, just kind of a refresh or brushing up your knowledge, you take care. Okay, you take like that. So data integrity constraints are very much important in order to implement our business rules into system. So why we require these business rules to implement these things? Okay, because to reduce the developer's time. Okay, forget about now you are a data modeler, just you are a developer now. To reduce a lot of work of data based developer, this is required. Example, this integrity constraints are categorized into 3. Okay, entity, domain and referential. Example I'm going to tell you. Entity integrity means primary key. Under entity integrity you get primary key and unique constraint. Okay, what is primary key? Primary key usually is used to identify your rows in a table, correct?
Yeah.
In order to identify your row in a table, we require primary key. That's what employee ID, customer ID, location ID, all those things. Okay, and this ID should not be repeated. Generally business requirement is there should be a column which is used to identify a row, and that column should not have duplicate values because it is identifier, and that column should not have null values also. This is a requirement. For that, what you have to do? If there is no primary key, we have to write a program, correct? We have to
Yeah.
write a program. It could be any language you say, or is equal also. You need to write a procedure to ensure this table does not allow null values in that particular column. This table does not allow duplicates in that particular column. Okay. So when you write for that particular table, the same requirement is given for multiple tables. Yes or no? The
Yes.
same rule, same business rule for employee, same rule for customer, same rule for location, same rule for X, Y, Z. So when you need to write different program, same program, similar program for multiple tables, and you have to store that table, kind of a trigger, which works behind the screen for each and every table. Yes or no?
Yeah.
So every table you have to write this and store that. And whenever you are creating this script in other database, you have to give that script also. So tedious task, right? Writing that. Writing that is tedious task. Maintaining is a different thing. Okay. Writing for each and every table is tedious task. To overcome this, and this is a very common business requirement that what identified from your softwares RDBMS, they have given a concept called as primary key constraint, where it won't allow null values, where it won't allow duplicates, and it is used to identify the entire row. And the primary key can be created only one primary key can be created in a table, and this primary key can be created on a column, that is a primary key. If it is created on set of columns, it can be created on set of columns also, that is called as composite key or composite primary key. Or do you know this?
Yeah.
And by default it won't allow null values. Primary key does not allow null values. Null value means we don't know, it is unknown value. Null is not equal to 0, null is not equal to space. Null is not equal to null. When you compare null, we say null is null, correct? Use keyword is when you are comparing null values. So usually when we say unknown means null. What is your name? If you say I don't know, that is null. Generally it is not. We make the names are mandatory. Email IDs, mobile numbers, these are mandatory, means you cannot pass null value. We cannot say I don't know. Agree with me?
Yeah.
Okay, coming to unique. Unique means the name only says does not allow duplicates, but unique means it allows any value for one time including null value. It allows any value for one time including null value. And this is in a table you can have multiple unique constraints like email ID, mobile number, PAN, Aadhaar, SSN, passport. Such columns are possible to which has unique values. Each and every person can have only one as such. Okay, such columns we have to define as unique because primary key we cannot create. Agree with me?
Yes.
Because you know this, I am doing fast. Aniket, let me know if you feel not
Yeah.
comfortable. I'll go slow. Okay,
Yeah. Yeah. Sure.
no objections on it. Okay, next. Unique, you can have multiple constraints, I mean multiple columns with unique constraints. That's about primary key and unique. So these are helping you to save a lot of time to implement the business rules, correct? Yes, for mobile number you have to write one more program. For passport you have to write one more program. Means for 10 columns which are similar to that, you have to write 10 types of programs to not allow unique duplicates, correct?
Yes.
Okay. So next is domain integrity. I'll stop here. We'll see domain integrity, referential integrity tomorrow. Okay.
Mhm.
And I'm not
Okay.
going to show you these practicals because you know you are a SQL and data warehouse resource, correct?
Yeah.
Do you want me to show practically? Let me know if you want.
No. No. Not. This. Not required.
Yeah, yeah. So these are all like brushing up. Okay, nothing serious on the modeling thing.
Mm-hmm.
As these are required to be a modeler, tomorrow when the tool whenever I say this is a primary key, you should have okay. I know this. At least we discuss in the session. Okay.
So are you able to see my screen?
Yeah.
Okay. So in the first class, we have discussed about the data model and their types. Okay.
Mm-hmm.
So now today, we are going to start the entities and the relationship.
Mm-hmm.
Like see, so we know we have three types of model: conceptual, logical, and physical. But one such popular model is also known as the ER model. Okay.
Mm-hmm.
So ER basically called the entity relationship model for any of the project that belongs to relational database management system having the ER model. So in which we are going to define the entities, then the relationship between entities and the attributes of an entity. Okay.
Mm-hmm.
So three things mainly depends for a ER model. First is the entities, second is the attributes, and third is the relationship. So if we talk about like what is an entity relationship model and why it is needed, because what we are doing in the data modeling will be a dimensional model that belongs to a data warehouse also, and some ETL process once comes into the picture. We also have to create a dimensional model in terms of conceptual, logical, and physical diagram. It means physical data model.
Mm-hmm.
But the ER model, what we have already in a RDBMS technology, that is called the databases that we are using currently for the Oracle, for the SQL Server, for the MySQL and all.
Yep.
Okay. So
Mm-hmm.
basically the ER model describes interrelated things of interest in a specific domain of knowledge. Like if we talk about the BFS banking and financial services domain, then alt first of all account and the account type, or customer, or we have a banking facilities, loans, then we have different types of uh, mutual funds, then a brokerage. All those things belongs to the entities of a banking and financial domain.
Mm-hmm.
Okay, so to start with a data modeling part, you must have to identify the entities of any domain, and then we have entity, entity set, and entity type.
Mm-hmm.
Okay, so entity, entity set, and entity type. Why it is needed? Because one of the terms, that is the metadata. So the entity type belongs to the metadata part. Why metadata part? Because ultimately when you are going to design a table having different types of columns, deleted columns, that will be the attributes of an entity.
Mm-hmm.
Okay,
Yep. Yep. Mm-hmm.
so for suppose you have a account entities. For a BFS domain, you have account entities.
Mm-hmm.
So what will be the attributes for an account?
For account entity, right? Just like account name, account type, and
Account account number, first of
mhm,
all. Okay,
mhm,
then we have account type, correct? Then
mhm.
again,
Account name. Account is also called an arrangement, right?
yes, it's an arrangement, and the not arrangement, you can say account and the customer. These two are the main entities of a system. System in
Mm-hmm.
terms banking and financial domain. Okay, so these
Mm-hmm.
two are called the main. What I'm saying. So main entities.
Mm-hmm.
So without these two entities, we can't assume the system.
Mm-hmm. Yep.
Okay.
Mm-hmm.
So I will explain later in the later sections what are different types of attributes and all those things. Uh, but what I'm so and in entities, for any of the system, we must have to identify the main entities of that system first. Main entity, it means it may be 3 to 4. Suppose for a bank will be also an entity, customer will be entities, in account will be entities, and so on. Okay, and later on we will see, is there any derived entities we can also identify, or is there any entity that we can um, create by the combinations, composite entities, and all. So if any of the system, I'm going to write, let me uh, see, for a banking and financial domain, for a banking and financial services, the entities will be, if we are talking about, first will be the customer, second will be the account,
Mm-hmm.
third will be our transactions,
Mm-hmm.
fourth will be our loans,
Mm-hmm.
fifth will be our credit cards. So credit cards and all those things that will come in our facilities. Okay.
Product, yeah.
Yes, products you can also say, or you can say our banking products.
Mm-hmm.
And for example, we can say one is the credit card.
Mm-hmm.
Okay. Now, if we have mean it means the base entities are customer, account, transactions, loan, banking products in terms of credit card. So these are the main or the base entities. We can say no, hey, these are the base entities of a system. And now we can just define the attributes like customer name, customer address, contact informations. We have account type, then the uh, attributes for account will be like account number, account type, then we have balance, interest rate, and that is called the ROI, rate of interest, and so on.
Mm-hmm.
Okay. Similar to the transactions, we have transactions ID. Can I write this, or is it fine to listen in
Yeah,
the call?
I think it's fine. Yeah.
We can write, or it's fine.
Yeah, it's fine. We are discussing in the call, so it's fine. Yeah.
Okay, that's fine. So we have in the account what we have discussed: account number, account type. It will be a current account or a saving account or all those things. Um, it will be a balance and the rate of interest. Okay, that is also called
Mm-hmm.
the ROI. For a
Yeah.
transaction similar to transactions ID, transactions uh, date, okay, transactions type. So what types of transactions that you are doing? Is there a deposit? So let me write this. So uh, for transactions, it will be a transactions type.
Mm-hmm.
Then we have tran date, that is called a transactions date, and the main part is the tran ID.
Mm-hmm.
Okay, and in transactions type, what we have multiple things. It will be a deposit, or it will be withdrawal, or it will be transfer. Okay,
Mm-hmm. Mm-hmm.
so these three things we can discuss mainly.
Mm-hmm.
So what we have in a transactions, either it is a withdrawal, or it is a deposit, or it is a transfer from bank to bank, or from any of the UPI that we are going to use. Okay.
Yeah.
and also we have amount, that is a part of the transactions,
Mm-hmm.
and uh, associated account informations, that is also the attributes of transactions, because if we are going to do a transaction, it must be uh, a account number, correct?
Yeah. Transaction which originated from an account, right? Yeah.
Yes, originated from an account and transferred to an account.
Yeah.
So there will be two account information needed. That's why I've given a single term, associated account information and all. Loans, similar way, we know bank loans, then we have, sorry, home loans, personal loans, gold loans, and so on. So these three, the main loans, what a bank is going to provide basically: home loans, personal loans, and gold loans. Okay.
Mm-hmm.
And same for the banking products, if we have multiple things like mutual funds, like the credit cards, like the smart cards, or any debit card is also a product. If we talk about a banking product, then we have multiple things like uh, credit cards, okay, like the debit card is also a product, because they are going to take a annual charges on their usability, or a fixed charges also is there on the, that is also called the base price or the base charges for a debit card. Okay.
Mm-hmm.
And can you say the other name of banking products what we have?
Just like debit card, credit card, home loan, personal loan,
Home
and
loan, these two sections comes under loans.
mhm. Okay, yeah,
Loan,
yes.
home loan, personal loan, and gold loan, that comes under loans.
Mm-hmm. Yeah. So I think in the
Bank,
banking,
yes,
yeah, debit card, credit cards would be the banking products, right? Yeah.
yes. And one also that you're going to use in the supermarket, like the Sodexo, and some other things also. So,
Mm-hmm.
so Sodexo, or a like coupons that is given to bank to an organizations, and it will be distributed from organizations to the employees.
Mm-hmm.
So when you go for a market, you don't have to pay, because it already paid by the employer, um, in sense of from the employee side, like coupon vouchers and so on.
Mm-hmm.
You can see the vouchers as a general term. So the bank is also going to provide some vouchers, like
Mm-hmm.
a ICICI Bank or a Duce Bank, Bank of America, and so it's going to provide some vouchers to the customers so that they can do it transactions from the voucher.
Mm-hmm.
Okay, so these are the banking products, and if we talk about a particular products like a credit cards, then they have multiple attributes like credit card number, the card holder name, then we have credit limits, balances, transaction history, CVV number, and so on.
Mm-hmm.
Okay,
Yep.
but we are not going to capture the CVV and the expiry in the attributes, because these are the secure informations, PIP.
Mm-hmm.
Okay, so in general, we can say credit card number, the holder name, limits, balance, and the transaction history.
Mm-hmm.
Okay, so these five terms are the main attributes of BFS domain. That is also called the banking and financial services.
Mm-hmm.
Okay, I will explain every aspects, how we are going to use, what is the purpose, and so. So in the later slides, we have entities. I discuss in this slide, we have entity set, and entity type.
Mm-hmm.
So what is the meaning of these three terms? Entity set, and entity type?
Yeah, entity is just like a
Real
just
world
like
object.
yeah,
Okay.
it's a kind of a table, right? Yeah.
Yeah, it's a kind
And
of table. And in terms of databases, if we talk, it is an object that belongs to any system. Okay.
mm-hmm.
An object, it means in the RDBMS forms and the technology, it is a table and it
Mm-hmm.
is.
Mm-hmm.
So now, if we talk about a entity set, so entity set is a collection of entities.
Mm-hmm.
So if we have a employee entities, so E1, E2, E3, E4, and En. Okay, so this is called the entity set. E1
Mm-hmm.
is employee, E2 is employee, E3 dot 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 anything. En also is an employee. So in a
Mm-hmm.
ER diagram, basically we can say the entity type is represented under a boxes, and we can say so employee is an entity, but these things E1, E2, E3, E4 are called the entities set.
Mm-hmm.
Okay, and if we are talking about the entities type, then we have multiple entities.
Mm-hmm.
So independent entities, dependent entities, and the characteristics entities.
Mm-hmm.
So independent entities are saying that is not based on anything like employee. So employee, so come to the banking and financial domain. If we have account, okay, and if we have account that belongs to a customer, and customer is our independent entity.
Mm-hmm.
But if we talk about the account type, then it will be a dependent entity. Why dependent entities? Because every account will be dependent on a customer.
Mm-hmm.
So we have multiple types of entities that we need to identify, but in general scenarios and in general life, we only need to consider so the main entities of a system first, and then how we're going to define the derived entities from that system.
Mm-hmm.
Okay, so
Yep.
two things basically needed: independent entities and a dependent entities, because
Mm-hmm.
when we are going to define the entities uh, of system or of a domain, then later you will work on the attributes part.
Mm-hmm.
Okay, so dependent entities, we can say.
Yeah.
So in independent entities, we have few examples like for a company database.
So we have seen what is data warehouse, what are the characteristics of data warehouse, and we need to see about what is data mart. Okay, if we see there is a huge volumes of data, so that's what I was explaining in the last session. uh, yeah, I'll explain here only. We are discussing about what is data mart. Okay, let me explain you here only what is data mart. If you remember the last diagram which I explained you how the database comes and how you got data warehouse into picture and the reporting part, do you remember that, Isaac? Do you remember the
Yeah, yeah,
diagram which I was telling you? So
yes,
where
yes.
we had databases. Let me get you the pen and write. Today I'll be taking a very short session. Please don't mind. Okay.
Okay.
Okay. Because again, I have meetings. That's the reason. Please don't mind. So if you remember, I told that we have multiple databases. Okay, like this, and we kept all those in the one database that is called as ODS, Operational Data Store. These are all OLTP systems, like transactional systems, means normal databases, and we can get reports from either of these two based on your requirement. As the size of the data keeps increasing, what we do is we go for data warehouse. Agree?
Yes.
The size of the data warehouse and the data increases and the performance of the reports go low or does not perform better, we go for data warehouse. So in the data warehouse, data is organized in such a way based on the denormalization, based on the subject oriented non-volatile transaction, what is that, integrated. Okay, remember the features. Here we discussed 4 features: subject oriented, time, non-volatile, what is that one more, time period, based on different time periods we can see, right? See here, time variant and integrated. Integrated means we are integrating data from multiple sources and keeping in data warehouse, and as a complete history is there in this data warehouse, you can see the data based on year wise, month wise, quarter wise, whatever the time periods you want. And non-volatile means permanent. Whatever the changes you made to this data warehouse, it is going to get saved, it is going to get saved to that permanently. Got it? Getting
Yes,
me?
got it. Yes.
Okay. Next, this data warehouse data has huge volumes of data. Now you can get the reporting based on this also by writing some SQL commands here or stored procedures or whatever. Correct? Now just think, same process is there. So you have multiple sources. You have ODS, or this is optional. This is not mandatory. ODS is not mandatory. From their data warehouse, so you are getting reports out of it, either of it. Okay. Now the performance of this also may go down after certain time. Correct? Let's say there are some 200 reports. Okay. See, these are not part of syllabus. These are just for making you understand how we need to think, how we need to go for a better practice based on the requirement. Okay. These are not part of syllabus. This is very, very general knowledge I am giving. Okay. Getting me right? Okay. So if we see here, this data is broken into smaller groups. Okay. In order to serve the reports better, this smaller groups is called as data marts. Again, these are divided based on different requirements, based on the reports, based on the subject categorized here. Okay, multiple data marts are defined. So this is derived from this data warehouse. This is derived from this data warehouse. This is derived from this data warehouse. So this called as piece of data warehouse or slice of data warehouse or subset of data warehouse, and this is called as data mart. This is called as data mart. Okay, so now there are 200 reports. There could be some 10 reports or 20 reports which might be pointing to some, let's say some 7 tables or 8 tables. Okay, 10 reports are pointing to 8 tables. Instead of pointing to complete data warehouse where huge volumes of data is there, you just create a data mart which consists of those 8 tables and create and keep a separate copy here, so that this overall holds less volumes of data. This works better to this. than this. Instead of searching entire data warehouse for these 8 tables and getting the data, just you have only 8 tables, it is easy to get your 10 reports faster. Am I right? You're getting me?
Yes.
Let me know, please. If you are not understanding, I can help you.
I'm getting it. I'm muting myself to kind of remove the background noise.
What is it?
I'm saying that I'm muting myself so that we kind
Okay.
of the background noise.
Okay. Fine. No issues.
We can
Okay.
continue.
Yeah, I'm continuing. So you got right. This is a small set of data warehouse that is called as data mart. Okay. A small set of data warehouse called as data mart. Next. Next is this. This is going to help for your reports, which works better than pointing to this. This, whatever the process we followed, is called as forward engineering, of course, but these data marts are depending on the data warehouse, correct? These data marts are depending on this data warehouse. That's why these data marts are depending on this data warehouse. That's why these data marts are called as dependent data marts. These data marts are called as dependent data marts. Clear, right?
Yes, clear.
These data marts are called as dependent data marts. So there is other way. There is other way where same process is there, like databases, ODS. So your history data, let's say you're a small company, you don't want to invest on the huge infrastructure like a very big data warehouse. You don't want to invest any much on data warehouse. Okay. In that case, how do you do? What you do is you may go for a data mart directly. You don't go for data warehouse. You build your own data mart and you build one more data mart. Like that, you keep building your data marts and you keep developing your reports which are required. Okay. And later, if you want a data warehouse, or if your client asks, then you can go for a data warehouse and build your data warehouse based on these data marts. So these data marts are not depending on the data warehouse. These are called as independent data marts. These are called as independent data marts. Hope it's clear. Moving on.
Yes.
Let me go through the notes. Data mart is a smaller version of data warehouse. Data mart is a smaller version of data warehouse. Data mart deals with single subject, as I told earlier, subject oriented. Data mart is subset of data warehouse, or it's a slice of data warehouse. Okay. There are two types of data marts. One is dependent data marts, another is independent data marts. Dependent data marts means in our traditional flow, in our regular flow, forward engineering flow, where there is a transaction system. Based on the transactional system, we build a data warehouse, means transaction system or multiple transactional systems. We build our data warehouse. From the data warehouse, we build our data marts. This is called as dependent. Okay. If you go for reverse way, where you are building directly data mart, you are not connecting to data warehouse. Means you are not introducing the concept of data warehouse. Directly you are implementing the data mart from your transaction system. Then it is called as independent data marts. Data marts are not depending on the data warehouse. Okay. Is it clear? ODS is nothing but operational data store. All the operational data you keep in one place, that is called as operational data store. Hope you remember in the very first session we discussed about OLTP and OLTP, OLTP and OLAP, online transactional processing system and online analytical processing system. Do you remember that?
Yes.
So ODS also part of OLTP. ODS is also part of OLTP only. Okay, clear? This consists of only operational data. Coming to data warehousing concepts. Okay, let me tell about what is dimensions, what is facts today. We'll continue tomorrow with the snowflake. Okay, tomorrow I'll join on time. I request you also please join time. Okay, fine, right? Coming to,
Okay.
if you know, I don't know whether you know database or not. In database we have two types of tables. One is master table, one is child table. Okay, or detailed table. Master table is the one which has primary key, which does not allow duplicates, which will not allow duplicates, and is mainly gives the textual information or descriptive information. Okay, child tables are the one which may have primary key, but it will have foreign key referring to this table, referring to the master table. It may describe about the entity or it may have some transactional information. Transaction information means what are all the transactions a particular person has done. Okay, means transactions means the same, for the same customer it is repeated again and again. Okay, clear, right? So
Yes.
transaction means every transaction whatever you do there will be one record, but is it a master record? No, it's in the child table. It refers to the customer ID, it refers to the particular employee or particular, so basically it refers to the master table, I mean to say. Okay, next. So here in data warehousing also, we have our tables divided into two types. Our tables are categorized into two types. One is dimension, one is fact. Dimension is the one which hold the primary key, which does not allow duplicates. No duplicates, it won't store any duplicate info, which tells about the business. Which tells about the business means which tells about entity, basically. Means textual data it will store. It stores a textual data. Hope it is clear, correct? That is dimensions. So basically this can be master tables. Coming to fact table. Fact table has or will have a foreign key to the dimension tables. It might have foreign key to one or more dimension tables. It consists of all the transactions and it consists of all the numerical data. All the numerical data. Here it is textual data. It will consist of mostly numerical data. All the columns are numerical, like sales amount, tax amount, freight charges, okay, anything such things. Okay, all numerical data. As this consists of the columns, as is a table, this is a table where it has the columns which holds only numerical data. Numerical data means measurable data, which can be measured, right? Which can be calculated, correct? Which can be measured or calculated. These columns can be called as measures. Instead of columns, we can call as a measures. As a fact table consists of group of measures or group of columns which has measurable values, this can be called as measure group table. Here dimensions columns are called as attributes. In the columns in the dimensions are called as attribute or dimensions attributes. Okay, so that is about dimensions and facts. See here, dimension master tables are called as dimensions. Dimensions hold the master data, it won't have the duplicates. Information about the business is stored, it has a primary key. Okay, dimensions are the tables which are used to store the textual information about the business, which has a primary key. Dimension columns are called as attributes or dimension attributes. Columns in the dimensions are called as attributes or dimension attributes. Dimension tables always deal with character, var character, n character means these are all the data types, string data types. Measurable, fact table. Fact table deal with the data related to the values, means numbers, which can be calculated, which can be measured. Example, sales amount, tax amount, price, salary, age, weight, height, etc. Any numerical data. Fact table has columns. Those are also called as measures, as these are all measurable values. Fact table is also called as a measure group table. So fact table refers to the dimension table. Are you clear on this? Isaac, are you
Yes,
clear
it's
on
clear.
this? Okay. And I'm sorry, I'll stop the session here because I have other meeting in 5 minutes. Actually, I should join by now. I told that I'll be late for 5 minutes. Tomorrow we'll continue on schemas. Okay, types of schemas, and
Okay.
we'll see next topics. Okay, types of dimensions, types of X. Tomorrow we'll try to complete this theory part. Okay.
Okay.